And in this problem, our goal is to use a graph and use what we know about x-intercepts and critical points to write a quadratic function. So let's go ahead and actually label a couple of key things. We have an x-intercept right here, and this x-intercept seems to occur at -1, 0. And it does. I mean, I know for sure that it does. And then this one occurs at 4, 0. So we have two x-intercepts. That's important information. And we just need a third point. In tonight's homework, I had intended you to use the maximum. On this graph, the maximum isn't very easy to read. I think on the homework, the maximum is pretty easy to read, so you please use the maximum. But the most important thing is you need these two and then any other point that's easy to read. In my opinion, on this graph, I think the y-intercept 0, 12 is pretty easy to read, so I'm going to use that. I think you can use the y-intercept on tonight's homework. I think it's 6, but you can also use the maximum value. You need a 1, 2, 3 points. That's the most important thing. Okay, so first thing we do is take our two factors and use them, or not our two factors, our two x-intercepts to write the factors of our function. So let's write out y equals k, and then if -1 is an x-intercept, we know that x plus 1 must be a factor, right? Because your factor is always the opposite sign for your x-intercept. Here, if we have a positive 4 x-intercept, we know x minus 4 has to be part of the factored form of the quadratic. So we know this piece from this x-intercept, we know this piece from this x-intercept. The only thing we don't know is the k value, and that's where that third point is going to come in. What we're going to do is take 12, which is the y value, and rewrite it in place of y. So y is 12. K is unknown. And then we're going to use the x value of 0 plus 1, and then once again that x value of 0 minus 4. At this point, we have an equation that has only one unknown, which is k, so we can solve for that unknown and find the k value. So let's just do a little simplification. 0 plus 1 is 1. 0 minus 4 is -4. Do a little more simplification and we get 1 times -4 is -4. So this is 12 equals -4k, or k times -4. Either one's fine. The most important thing is now we need to divide and divide. Divide by -4, divide by -4. And what we get is k equals -3. So it lets us know that y equal -3, x plus 1. Oops. Let's make a little room. -3, x plus 1, x minus 4 is the function that would look exactly like this graph. Not just kind of. If you graph the x-intercepts, you get these 2 points. If you also use -3, you get the specific function that includes this point, but it would also include the maximum and any other points. We could go a little bit farther and rewrite this in standard form. So if we use the distributive property, which was in a review assignment from the other night, what we get is x squared minus 3x minus 4. And then we can distribute this -3 and get y equals -3x squared minus 9x, I'm sorry, plus 9x plus 12. And this step wasn't really required for the homework. It's just using the distributive property. I know I did blow through the steps pretty quick. But the most important thing for tonight's homework, those two x-intercepts, write those out as factors using the opposite sign. That third point, plug in the x value for your x's and the y value for the y's. Make sure you've written it out like this, and then solve for that k value. And I will totally accept kind of this as satisfactory work for tonight's homework. I would try to simplify it, but this is the most important part of the assignment.